Hello friends, welcome to our channel. In the previous session, we have discussed regarding the point clipping, and we have seen 4 conditions, and for every point these 4 conditions to be satisfied, and only when all these 4 conditions are satisfied, then only such points should be considered, and that means such points are lies inside the window, and if any one of the condition fails, that indicates the point is outside the window, so those points should be clipped. And for doing this purpose, the first and foremost thing we have to do is we have to define a window. That means a window with a boundaries of x and y. So window boundaries should be xw minimum and xw maximum, yw minimum and yw maximum. So first of all, we have to define a window, and then we have to follow the procedure. And in this session, let us have a look on line clipping algorithm. So in the previous session, we have seen a point clipping, that means we are considering a points, and here in this session, the line clipping, that means we have to consider a line, and the line which lies inside the window should be displayed, and the line outside the window should be discarded. That means clipped. So for example, here also we have to define a window with the boundaries xw minimum, xw maximum, and yw minimum and yw maximum, and consider the lines. Let it be, this is P1 and P2, P3 and P4, P5 and P6, P7 and P8. So here there are 4 lines: P1, P2, P3, P4, P5, P6 and P7, P8. Now after clipping, so here we have to display whatever the lines inside the window, and we have to discard the lines which are outside the window. So consider the P1 and P2. So here by visibility, P1 and P2 lies outside the window, so this P1 and P2 is clipped. That means discarded. Coming to this P3, P4. So both the points are in the same window. That means we have to consider, or simply we can say accept. Here we can say reject. And P5, P6. Here P5, P6, some portion lies inside the window and some portion lies outside the window. So here clipping is required. Sorry, here P1, P2 both are outside, so the clipping, no clipping must be considered, so it is simply reject. So here P5, P6, in the case of P5, P6 line, some portion lies inside the window and some portion lies outside the window. So we need to clip the portion which lies outside the window. And similarly P7 and P8, here also some portion is inside and some portion is outside. So here also the clipping is required. Here also the clipping is required. So one thing is, just find out the boundaries, that means P1 coordinates and P2 coordinates, and apply the point clipping. So if both the points are outside, just we can simply reject. So consider the points P3 and P4, apply the point clipping. So if both the points are inside, consider the line. So all the intermediate points in between P3 and P4 also lies inside the window. So P3, P4 line is inside the window. And coming to the P5, P6, so consider the line. So here we can't apply the conditions, we can't apply the point clipping. So for this purpose, we are moving to one algorithm called line clipping algorithm, that is Cohen Sutherland algorithm. Cohen Sutherland line clipping algorithm. This is one algorithm in order to clip the lines. So here the algorithm runs based upon the region code. Region code. Here also first we have to define a window. So and we need to define the region codes, and based upon the region code we will apply the clipping. So region code is a 4-bit code. 4-bit code. So first we have to define a window and identify all the neighbors of a window, and for all the neighbors of a window we need to define this 4-bit code, and then we have to apply the clipping. So here consider a window. Consider a window. So identify the neighbors. So this is the window and these are all the neighbors. So as I said that we have to fill the region codes for these neighbors. So initially the window, in the window this 4-bit code is all zeros. All zeros. And here the region code we can use ABRL. So we can fill these regions by using this ABRL code. A is above, B is below, R is right, L is left. So here we can apply ABRL. So A means above, B is below, R is right, L is left. So all these are the 4 bits, and based upon the neighbor we need to set the bit. So initially the window region code is all zeros, and coming to this is a topmost for the window. So that means above, window above. So above bit will be set to 1, that is 1, and all the remaining is zeros. And this is below to the window, that means below bit must be set to 1 and all the remaining bits will be zeros. So 0, 1, 0, 0. And this is rightmost to window, so right must be set to 1 and remaining are zeros. And this is leftmost, that means left bit must be set to 1 and remaining will be zeros. And filling these corner regions can be done by using 2 ways. One is simply you can XOR these 2 region codes for getting the region code of this corner, and for getting the region code of this corner simply do the XOR operation of these 2 region codes, and XOR operation of these 2 region codes will give the region code of this corner, and these 2 region codes XOR operation will give the region code of this corner. That is the one thing. And another thing is simply apply the ABRL code. That means here this region is left and above, left and above. So consider left and above, that means 1, 0, 0, 1, ABRL, left and above. This is left and below, that means 0, 1, 0, 1. Right. So you can simply observe the XOR operation of these 2 region codes is 1, 0, 0, 1, and the XOR operation of these 2 region codes gives this 0, 1, 0, 1. And this is right below, that means right below 0, 1, 1, 0, right above 1, 0, 1, 0. Hope you understood this filling the region codes. That means initially the window is all zeros, and based upon the ABRL code. So it is not a fixed, ABRL code is not a fixed. You can use LBRA, LRBA, whatever it may be, whatever code you may be, you can use to fill the region codes, no problem. So most probably we can use this ABRL code, above, below, right and left. And after filling all the regions of this neighboring windows, now consider each and every line. So let us consider the above example. Consider the P1 and P2. So apply the region codes. The region code for P1, that means here in this position, that means here, this one, right? So just extend the window for easy identification, so that you can easily understand. So P1, the P1 region code is 1 and P2 region code is same. So we have to observe that if both the points, that means end points, if both the end points of a line are non-zeros, apply the AND operation, so that we will get a non-zero. So this is a non-zero and this is a non-zero, and if you get the result also a non-zero, that implies the line is completely outside the window. So once again let us clarify that. So first consider the point, the line P1, P2. So first identify the region code for P1 and identify the region code for P2. And if both the P1 and P2 are non-zero codes, that means here these are non-zeros because 0001 and 00001. So here both are the non-zeros. Apply the AND operation. So for whatever it may be, for every point we will apply the AND operation. So here we apply the AND operation and we get again a non-zero. If you get again a non-zero, that indicates the P1 and P2, that means that line, considered line is completely outside the window. And consider the next P3 and P4, the line P3 and P4. So the result of this is a reject. So clipping is not required, just reject the line because the line lies outside the window. And consider the P3 and P4. So find out the region code of P3, that is within the window, that means 0. P4, that is again 0. Apply the AND operation. Apply the AND operation. So this is a 0 value, this is also a 0 value, and AND operation, obviously we will get the 0 value. So because AND operation means if both the bits are 1, then only the result will be 1. If any one bit is 0, obviously the result will be 0. So here both the points are zeros and the AND will also be 0. So in such case, this indicates that both the points, that means the line between these points lies inside the window. So line is inside the window. So no clipping is required. That means we will just accept that line. Just we will accept that line because both are zeros and AND operation is 0. That means both the line lies within the window. So no more clip operation is applied. So clipping means we are just discarding the outer portion of the window, the portion which lies outside the window. So here the P3 and P4, the line is, complete line is inside the window. That means no clipping is required, so the line is accepted. In the previous case, the complete line is outside the window because both are non-zeros and AND operation is also non-zero, so that indicates both the line lies outside the window, so simply we can reject. Here also no clipping is required because we are just rejecting the complete line. And the third case, coming to the third case, consider P5 and P6 procedure. So region code for P5 is, so here that is 1000. Region code for P6 is 0000. Here AND operation. So this is a non-zero and this is a zero. So if one point is non-zero and another point is zero, obviously the AND operation will be zero, because when only if two bits are 1, then only the output will be 1. So here 1 0 means the AND operation will give again 0. This indicates, so here one point is non-zero and another point is 0 and the result is 0. So in this case means some portion of the line lies inside the window and some portion of the line lies outside the window. So clipping is required. Clipping is required. So some portion, so simply we can say partial. That means some portion lies inside and some portion lies outside. In such case, we need to find the intersection point. Intersection point on a window. Consider the intersection point on window. That means this one. So this is the intersection point. So let us label it P5 dash. So again consider the line P5 dash and P6. So P5 dash, the region code is within the boundary line, that is all zeros. Similarly P6, that is also all zeros. So both are zero values. Obviously AND operation will be 0. That means the line lies inside the window, right? So P5 dash and P6 lies inside the window. And what the portion is to be clipped, that means P5 to P5 dash is clipped. P5 to P5 dash is clipped. And just consider P5 dash and P6. The line P5 dash and P6 is considered. P5 dash is clipped, that means discarded. So three cases, one is completely outside, another one is completely inside, and another case is partially inside and some portion is outside. So whatever it may be, consider the 2 points of a line, end points of a line, and apply the region codes, find out the region codes for both the points and apply the AND operation. If both the points are having a 0 region codes, that implies the complete line is inside the window. And if both the points are non-zeros and AND operation is also a non-zero, that indicates the complete line is completely outside the window. And if 2 points are non-zeros and we get the result AND operation as 0 value, that means some portion of the line lies inside the window and some portion of the line lies outside the window. Consider the next case, that is P7 and P8. P7 and P8. Here also consider the P8 region code, that is 0100. P7 region code, that is 0010. apply the AND operation. So this is a non-zero value, this is also a non-zero value, and after applying the AND operation we get the zero value. So if we get the zero value, that indicates some portion is inside and some portion is outside. Now consider the, so now we have to, so the result is partial. So now what we have to do is we have to find the intersection point on the window boundary. So let us consider the intersection point P7 dash. So P7 dash, intersection point is P7 dash. So P7 dash and P7 is clipped, and consider the line P7 dash and P8. So consider this line P7 dash and P8. Now P7 dash, region code is P7 dash within the boundary, all zeros. P8, that is 0010. Here it is a zero value, it is a non-zero value, and apply the AND operation, we get zeros. This also implies, so one is zero and one is non-zero, and also the result is AND operation is zero, we get the zero. That means again it is a partial, that means some portion lies inside and some portion lies outside. So we need to repeat this process until we get both the points in a zero values. So again find out the intermediate point. Now I will find this intermediate point as P8 dash. So P8 and P8 dash is clipped. Consider P8 dash and P7 dash. So P8 dash, region code is 00, P7 dash, region code is 000. So total AND operation finally 0000. That means, so this is a zero value, this is also a zero value, and the result is also a zero value. So that means the complete P8 dash, P7 dash lies inside the window. So we need to consider this line, and P8 dash is clipped. So we have to repeat the same process. So first finding out the region codes for each point and applying the AND operation. If both the region codes for 2 points are non-zero values and we get the result as a zero, that indicates some portion of the line lies inside and some portion of the line lies outside. Similarly, if one point, region code of one point is non-zero and region code of one point is zero, that indicates, and the AND operation is zero, that also indicates some portion lies inside and some portion lies outside. If both the points are having a zero region codes, that means the complete line is inside, and if both the region codes for both points are non-zeros and the AND operation is also a non-zero, that implies the line is completely outside the window. So we need to reject that particular line. And here is some case. See, if you consider a line from this region to this region, see, this is also another case. Let us consider P9 and P10. One more case. P9 and P10. So apply the same as we have discussed now. Apply the region code of P9. So P9 region code is 0001. Next P10. P10 region code is 1000, and apply the AND operation. It is 0. So it is a non-zero. It is a non-zero. The result is 0. So till now, so we have discussed that if both the points region codes are non-zero and if the AND operation result is a 0, it indicates some portion lies inside and some portion lies outside. But in this case here, P9 and P10, so the complete point is outside the window, and here also P9 is having a non-zero value, P10 is having a non-zero region code, and applying the AND operation 0. So it indicates, even though we get the end and result as 0, that implies the line is outside or partially inside.